Today we will be focusing on multiplying and dividing rational expressions. Before we see examples of that, I would just like to multiply using our properties of exponents. Remember, when we multiply fractions, we go across the numerator and across the denominator. For example 6 and 7, we're just going to assume that all expressions are defined, meaning we're not going to worry about stating where the function is undefined, meaning when the denominator is equivalent to 0. Once again, like I said, when we multiply fractions, we go across the top and across the bottom. Starting with the numerator, I'm going to multiply my constants together first. 2 times 15 is 30. X squared could be multiplied with, or x to the fourth power can be multiplied with x squared. Remember, when you multiply two things together that have the same base, we add the exponents. So 4 plus 2 is 6. And then y to the fifth power would just remain the same since there's no y in the second numerator. In the denominator, 3 times 8 is 24. X squared times x cubed would be x to the fifth power since I would add those exponents. And then y squared would just remain the same. Now we would like to simplify as much as we possibly can. I'm going to start with the constants. 30 and 24 are both divisible by 6. So 30 divided by 6 would give me 5. And 24 divided by 6 would be 4. Next, I'm going to look at the x's. We're going to be using quotient property, which says we subtract the exponents. 6 minus 5 is 1. So it's x to the first power. And now taking a look at the y's, 5 minus 2 is 3, so I have y cubed here. Example 7, once again you go across the top, across the bottom. It doesn't matter that there's 3 things we're multiplying here instead of 2. So when I multiply the numerators, I would get 20x to the 8th power because I added the exponents here. In the denominator, I would have 15 times 2, which is 30, and then x times x to the fourth, which is x to the fifth. I'm going to simplify it the same way. Look at the constants first. So 20 over 30, both are divisible by 10, so that's a 2/3. And now looking at the x to the 8th over x to the 5th, 8 minus 5 is 3, so that's x cubed, making our final answer 2x cubed over 3. All right, take a look at example 8. You'll notice that I have the steps written in the left column and I have the example in the right column. So we're just going to follow these steps together. You can multiply rational expressions the same way you multiply fractions, so going across the top and across the bottom. But before we do that, we're going to do step 1, which is to factor all numerators and denominators completely. The numerator here in my first term is x plus 2. That cannot be factored any further, so I'm just going to put x plus 2 here. The denominator of the first term can be factored. We have a 3x plus 12. So I'm going to factor by pulling out a GCF of 3. When I pull out a GCF of 3, in parentheses, I'm going to write what remains, so what I get when I divide each term, which is x plus 4. So I am now going to rewrite the denominator of my first term as 3 times x plus 4. In the second term, my numerator is x plus 4, which cannot be factored any further. But I am going to try and factor the denominator of the second term. So the denominator of the second term is x squared minus 4. This is actually a special case. It is a difference of two squares. If you were to ask yourself what squared would give you x squared, the answer is x, so a is x. And what squared would give you 4 is 2. So a is x, b is 2. With a difference of two squares, it looks something like this. A squared minus b squared equals a plus b times a minus b. So the factored form of x squared minus 4 is x plus 2 times x minus 2. That's what I'm going to write for my denominator. Step 2 is to multiply the numerators and then multiply the denominators. Like I said before, when you multiply fractions, you go across the top and across the bottom. So I now have x plus 2, that expression, being multiplied by x plus 4 over 3 times x plus 4 times x plus 2, x minus 2. Step 3 is to divide out any common factors of the numerator and denominator. So if anything's the exact same, we can cancel them out. Looking here, I see I have an x plus 2 in the numerator and the denominator. I also have an x plus 4 in the numerator and an x plus 4 in the denominator. So now, if we write what remains, I don't have anything in the numerator. But it doesn't magically disappear. I do need a placeholder here, so I'm going to put 1. Because technically, x plus 2 over x plus 2 is 1, x plus 4 over x plus 4 is 1. Just like how 2 divided by 2 is 1. Anything over itself. In the denominator, I would have 3 times x minus 2. Step 4 said be sure the numerator and denominators have no common factors other than 1. So I'm just checking and seeing, can I factor any further? Is there anything else that cancels? Did I miss something? Is there a GCF? The answer is no. So this is, in fact, my final answer. We're going to try this process once again, following the 4 steps that I have listed above. Step 1 is to factor the numerators and denominators. The numerator of the first term can be factored by pulling out a GCF. The denominator of the first term is a trinomial where a equals 1, so that's going to be our guess and check method. The numerator here cannot be factored any further, and the denominator here can be factored by pulling out a GCF. Go ahead and factor these and then hit play when you are ready. Let's see how you did. The numerator of the first term is 10x minus 40. I mentioned that we're going to pull out a greatest common factor of, in this case, 10. So I have 10x minus 4. 10x minus 4. The denominator of the first term I had mentioned is a trinomial where a equals 1. So we're going to use guess and check. If I have x squared minus 6x plus 8, I'm going to look at the factors of a positive 8. That positive means I'm using same signs, remember? So the factors are 1 and 8, 2 and 4. Using same signs, I need to get to a negative 6. So I'm going to put a -2 and a -4 to get a -6. That means my factored form is x minus 2, x minus 4. We had mentioned the numerator for the second term does not factor any further, so I'm just going to go ahead and rewrite it. And the denominator can be factored by pulling out a GCF. The GCF here was 5, so 5 times x plus 3. Step 2 is to multiply across the numerator and the denominator. So I'm just going to rewrite this as 10 times x minus 4 times x plus 3, just showing everything that's being multiplied together. And then I'm going to rewrite the denominators as being multiplied together. I'm also going to take that 5 and move it out front, because that's going to make it easier when I'm simplifying the constants. Okay? Now, let's go ahead and cancel out any common factors of the numerator and denominator. So I can see that I have an x minus 4 that can cancel and an x plus 3 that can cancel. And we would like to simplify what remains. So I now have a 10 over 5x minus 2. Step 4 is just saying, okay, have I simplified all the way? And the answer is no. The constants can simplify further. 10 over 5 is equivalent to 2 over 1, or just 2 in the numerator, and then I have x minus 2 in the denominator. If you'd like to still leave that in parentheses, that's fine as well, but I do want to say you cannot cancel the 2's, okay? It does not simplify any further. The reason why you cannot cancel the 2's is because it is x minus 2. We are dividing by this whole expression. The negative 2 is included with the x. All right, let's take a look at the next example. Dividing rational expressions is actually really just multiplying. You'll remember when dividing fractions, we used keep, change, flip. That's what we're going to do once again. We're going to divide the fraction by multiplying by its reciprocal. So keep, change, flip means we keep the first term. So I'm going to rewrite this as 4x cubed over 9x squared y. We're going to change from division to multiplication. And we're going to flip the second term. So we're going to use its reciprocal. And now we would solve it just like what we did on the front of the page with examples 8 and the try problem after. So when we multiply, we know we go across the top and across the bottom. So 4 times 9, that's going to give me, well actually I see something easier. Do you notice how I have a 9 here and a 9 here? It wouldn't be the worst thing in the world if you just went ahead and canceled that out. You could multiply the 4 and the 9 together, and then the 9 and the 16 together, and then go through the process of simplifying, but I'm just going to go ahead and cancel it out. So that means I'm going to end up with 4 over 16, which will also simplify. And then multiplying the x cubed and the y to the 5th. I cannot condense them because they're different variables, so they just stay. Same thing here in the denominator. I have an x squared and a y. So they just stay the same. I can't condense that any further. And we're going to simplify using our properties of exponents. 4 over 16 is equivalent to 1/4. So you could put a 1 here, or it's understood. I'll just go ahead and put it. So we have a 1/4. Using the quotient property, x cubed over x squared gives me x to the 1st power. Y to the 5th power over y to the understood 1st power is y to the 4th power. Step 4 is saying that we need to check and see if we can simplify any further. We cannot.